Welcome to Kenton's videos. Enjoy the video.
You begin by writing the matrix and immediately apply elementary row operations. This is where you make progress. First, choose a pivot in column 1 and, if needed, swap rows so the pivot is non-zero. Next, scale the pivot row to a convenient value if it simplifies arithmetic, and subtract multiples of that pivot row from rows beneath it to create zeros. Once you have zeros below the pivot, move to the next column and repeat. These steps establish row echelon form and reveal pivot structure. Now you continue pivoting across columns, moving left to right and down the rows. Make each new pivot in a lower row and different column. If entries in a pivot column remain scattered, use row additions to clear them. Once you have zeros below all pivots, optionally clear above each pivot to reach reduced row echelon form. This gives a cleaner picture. Throughout, keep track of non-zero pivot rows. Counting those pivot rows is how you compute the rank and understand the matrix's column independence. Finish by counting the pivot rows in your final echelon form. That count is the matrix rank, plain and simple. If arithmetic produced messy fractions, rescale rows or use integer-friendly pivot choices early to reduce errors. Make sure to cross-check. For square matrices, a non-zero determinant means full rank. For any matrix, verify that the set of pivot columns are linearly independent. If results disagree, rerun row operations from an earlier step to spot arithmetic mistakes.
Thanks for watching. Consider subscribing if we helped you.